Let's talk about the direct comparison test as a way to prove convergence or divergence for series. This is a test that basically uses your knowledge of other easier series to create comparisons. So here's a couple examples. So let's start with this. We've got natural log of n over n. Well, the series 1 over n is a divergent p-series. We've dealt with that already before. Remember, divergent because it's n to the first. Well, now imagine you took that series and you multiplied the numerator by a function getting infinitely large. Well, that means you made it bigger. So we could put an inequality in like this. Well, this was so large it had an infinite sum, and this one's even bigger. It must diverge as well. That's how we can prove divergence. Take a series we know diverges and show that all the stuff above it also diverges. Now this next one, 1 over n squared plus 3, the immediate comparison that jumps out to me is 1 over n squared. Well, this is a convergent p-series, and by adding 3, we made the denominator larger. If you make the denominator larger, you make the fraction smaller. So this thing converged. This other one is even smaller. It must converge as well. Remember, converge means you actually can find the sum. So that's direct comparison. This is not a test you use all that often. Essentially, it's, if you have something that, some series that converges and A is greater than B also converges. If A diverges and A is less than B, B diverges. All right, I want you to pause here and I want you to reason through this one. This is the example I always give of when you'd actually want to use direct comparison. But think about the maximum value of this numerator. Pause here and give it a try. All right, so here's how I would think about this. Sine squared of n. Sine squared is always between 0 and 1. So if you said, well, 1 over n squared, that is the maximum the numerator would ever be. So that's the inequality that would go between, I guess even equal to. Well, this converges. This must converge as well. This is a test you don't use an awful lot. It's important to know the relationship, that if we've got a convergent series, then the stuff below it also converges. If we've got a divergent series, the stuff that's greater than it diverges. But again, it's a test you probably use a different test for. Please like and subscribe for more of my Calculus Try It videos.